Thank you for your interest in this presentation. So this is a presentation I delivered during machine learning conference in San Francisco back in October 2022. In this presentation, I'm gonna focus on content understanding in feed recommendation. My name is Jay. So I'm a former director of data science at Kuaishou, and currently I'm leading content understanding efforts in Microsoft News and Feed. Since I'm only 6 months into this new role, so what I'm gonna present, this is gonna focus on the learnings and also the challenges I have observed. I will focus on the problems I have seen rather than focus on the solutions. As a brief introduction to myself, my name is Jay. I have a background in statistics. After receiving a PhD in statistics, I have been working in industry for over 14 years. I have been mostly working as a data scientist and a machine learning engineer. Throughout my career, I spent half of my time working as a data scientist and the other half working as a machine learning engineer. I have been working at a number of Bay Area companies and also companies in China, including Twitter, Stitch Fix, Snap, and Kuaishou. Um, as a quick summary, I have been focusing on search, advertising, and recommendations in consumer-facing products. Here's a brief introduction to Kuaishou for those who are not familiar with this product. It is the #2 largest short-form video platform in China. Based on Q2 earnings report for Kuaishou, it has 347 million daily active users, and each user spends on average of over 2 hours per day. During my time at Kuaishou, I was leading a data science and data analytics team. We worked on a number of different problems, ranging from content creation to video search to advertising. Right now, I'm working as a applied science leader in Microsoft WebXT. WebXT is a consumer-facing branch of Microsoft. It consists of the following 4 pillars of product. The first is Bing search. Next is advertising, and then Edge browser, and the last one is News and Feed. So I'm working in the News and Feed product. Here is the agenda of today's presentation. In the beginning, I'm gonna start with the introduction of our content understanding team. I will talk about the vision of the team, the scope, roadmap. Next, I'm gonna describe the signals in content understanding. I will show a simple demo of what signals we produce. I will also demonstrate the models we have been using and the challenges we have observed. At the end, I will talk about business impact of the work in content understanding. We'll talk about different use cases and how we onboard different models, and briefly talk about impact results. So what's the vision of our content understanding team within News and Feed? So the vision of News and Feed is to build a high quality, well understood feed content our users love and trust. And for content understanding, we are working on tagging every piece of content with high quality, comprehensive content understanding signals. Below shows a flow chart of how content understanding feeds into the overall recommendation system architecture. Our content comes from web, MSN, and also creator content. So we have an ingestion process that ingests our content into our index. After ingestion, it's going to be content moderation and understanding. Here, we try to understand the content and tag the content with content understanding signals. The content understanding signals could come from the editor's editorial judgments, and they could also come from the local marketing operations team. And of course, they also come from our machine learning models, try to extract signals from this content. With content understanding signals, the next step is personalized retrieval and ranking. And the personalized retrieval and ranking will surface a set of or a list of content which is personalized for this particular user. The user can see the recommended content on their Windows product, on Edge, and on Amazon website, etc. So this is an overall flow of our feed recommendation system. The charter of our content understanding team mainly consists of two pillars. The first pillar is content quality, which is to tag the content and creator with quality signals. Internally, we use different colors to represent content of different quality. Red typically means the content which contain harmful information and should be moderated. Gray means low quality content. It could be clickbait content or celebrity gossips. So the gray content should only be surfaced to the users who are interested in them. The next is green content, and the last is gold content. And the gold content are high quality content which we need to mine from our content corpus and promote to our end users. The second branch is interest tagging. In interest tagging, we are enriching content corpus by reliably tagging with high quality signals such as topics, entities, key phrases, clusters, and embeddings, etc. So we are trying to produce content understanding signals for our entire catalog for engagement purpose and for quality and partner satisfaction purposes. We are dealing with multiple sources. So we have Amazon licensed content, we have web, we also have user-generated content. We have multiple content types. We have text, images, and videos, etc. We are dealing with global languages. The models we build needs to be multilingual and can handle different kind of languages. We are dealing with multiple verticals, including news, shopping, sports, weather, etc. It's a wide range of content that we are trying to understand. Now let's take a look at the roadmap of content understanding. So I explained the roadmap in 3 stages. The first is in near term. We are building capabilities. The next is in the midterm. We are trying to build a content understanding platform. And in the longer term, we want to make broader contributions. In the near term, we are trying to build capabilities in the following 3 ways. The first is to do foundational work. This includes developing guidelines for different quality-related traits and guidelines for different topics. We also need to have benchmark data so that we can fairly and reliably compare different models. We want to have the entire flow of dev cycles from proposing new topics that our users are interested in, and we want to surface to our users to collecting the data for evaluation and training, and train the content understanding models, and then onboard these models. we want to have the bad case handling process to analyze the bad cases and suggest how we are going to improve our models. In the first stage, we are building up our data, our models, and use cases. For example, the local team is interested in understanding what content are crime content. There is a abundance of crime content in the local vertical, so we try to identify crime content and demote the crime content on our product. This is one of the use cases that we are working on, and we want to gradually build up multiple use cases. The different teams have been working on content understanding in silos. We have content understanding models from various different teams. It is our responsibility to evaluate the performance of different models, to integrate them into the single pipeline, and ensemble different models to achieve superior performance. So this is the first stage of building up the capabilities. Now let's come to the second stage, which is towards building a CU platform. So here we care about two things. One is comprehensiveness. We want to have a comprehensive taxonomy. We want to be able to map between different taxonomies. Our customers may give us a new taxonomy. We haven't collected data before. So with our existing models, how do we do content understanding for the new taxonomy? We want to build comprehensive dashboards and analytics, and we also need to have a data and model repository. The second point is autonomy. The autonomy includes self-served model training. We want to be able to allow the different stakeholders to collect data on their use case and to be able to train models on their own with our pre-trained architecture. We also want to allow them to have self-served signal consumptions. So they should be able to come to our platform, and for any topic they are interested in, they should be able to extract the content of their interest. The last phase is contribution. In the longer term, we want to contribute to the entire organization, be able to contribute to other business functions, and contribute to an external community. So we have covered the team introduction. Now let's go to CU signals. So in CU signals part, I want to give a demo of the signals we have, the models we have built, and the challenges we have observed. Now let's take a look at the demo of our signals. So this is an exemplar article. The article talks about Victoria Beckham explains why she just broke down at her Paris fashion show. So in this article, we can extract some basic signals like the title of the article, the URL, and the snippet from this article. So our snippet generation uses both HI and AI. Besides basic signals, we can also get tier 1 and 2 classification of this article. So our model suggests that this is an entertainment article, talks about lifestyle, and it has some probability, although very small probability of being news. Tier 2 is more granular than Tier 1. So in Tier 2, we have identified the following topics: the style, celebrity, and fashion. Besides Tier 1 and Tier 2 topics, we also have free tags. So the free tags do not form a taxonomy as in tier 1, tier 2, but it's a free set of tags that we can associate with this article. For example, for the article we just looked at, we have tags like fashion and style, celebrities, fashion show, and David Beckham, etc. We also have key phrases extracted from this article, and we can link the key phrases to our internal Satori entity, which is a repository with over millions of entities from Wikipedia. So in this article, we can extract Victoria Beckham as one of the entities, and within our entity repo, we know who she is, and we also know what kind of profession she has. So in the previous page, we have demonstrated tier 1 and tier 2 models, and also the free tags, as well as entity. Here is a demonstration of what kind of models we use for the different tasks. For tier 1 and tier 2, we use AxLNet, which is a 3-layer transformer model. And in building the models, we take a title and snippet as our key input. And the model is trained on record dump with some mapping logic. So in our internal data set, we have some human labeling going on to label the content into different verticals and subverticals. The verticals and subverticals can be mapped to our tier 1, tier 2 taxonomy, and we use a mapping logic to construct the training data. So in tier 1 and tier 2, we have achieved precision of over 90% and coverage of 90%. The next one is tags. So we have 100K tags, and this model is trained by AxLNet and also with title and snippet as input. So in training this model, we use both the MSN data and open source data from Quora and Wikipedia. So we have achieved a precision of 85% and a coverage of 90% in the text stamping. The last is entities. So the entity model can either be built by an end-to-end approach, directly take the content and output the entities. An alternative approach is to use a modular model. The current model has 3 modules. The first module is to detect mentions from this article, and then we use a search technique going from the mentions to match with to find candidates that we can potentially match to. And the last step is a generic matching to match the extracted content or the extracted key phrases with our internal Satori entities. So here our key feature includes the plain text and the Satori entities. And in entity model, we have achieved precision of 92%, but relatively low coverage of only 79%. In working on the CU signals, since we are still in the preliminary stage, we have observed the following challenges with different kind of signals. For tier 1, tier 2, currently we have 13 tier 1 categories and nearly 400 tier 2 categories nested within tier 1. So we have some challenges with the ground truth measurement data. So we need to have a large scale correct measurement data to be able to evaluate different tier 1, tier 2 understanding models. We are also concerned with taxonomy quality. For example, there are some topics which shouldn't appear in the tier 1, tier 2 taxonomy. So we have done some cleaning of the taxonomy to be consistent with industry standards. Another challenge is we often have vague labeling guidelines. So the one content could be either a health content or a lifestyle content, and our guideline often is not clear enough to be able to distinguish. For tags, we currently have 100K different tags, and it's a mixed bag of tags with different degrees of granularity. So some have high or some have high level of granularity, and some have very coarse level of granularity. We also have quality issues, and because we have such a large number of topics, we have a difficult time trying to calculate topic level precision and recall. For key phrases, this is a free form set, doesn't have a fixed set of key phrases. But for key phrases, we have issues both on the key phrase level, like the quality of the key phrase, and the diversity of the key phrases extracted from one content, and also the length or informativeness of the key phrases. We also have challenges with the matching or the relevance between the article and the key phrases. For entities, we are currently using a repository of around 1 million entities. We have good precision, but unfortunately we have low coverage. Another issue with entities is how to define interestingness or usefulness of an entity given an article. We don't want to list all different entities within the article, but rather we want to find out the most salient entities within this article. While working on content understanding, there are some dependencies here I want to highlight. In this table, I highlighted 4 of the challenges, but in this presentation, I will only talk about 2 of them. The first is trait definition and guidelines for content quality. For certain traits with respect to content quality, like clickbait, there's often a debate about what counts as clickbait and what shouldn't count as clickbait. So the risk is hard to achieve a good annotation with a lot of subjectivity and ambiguity going on. And this will also affect our model performance as well. In order to mitigate this issue, we have made the trait definition as objective and clear-cut as possible. We focus on well-defined subtraits or qualities first. We have also been using active learning, trying to use an active learning approach to assist guideline definitions. The other challenge I want to talk about is ranking usage. The signals we produce will need to be used by ranking so that they can generate a business impact. But we have observed there's a long turnaround for ranking-related experiments. In order to mitigate this risk, we have been working very closely with ranking team to enable faster experimentation. We have also been working on some tools to run served CU experiments, so we don't have dependency on the ranking team, but rather we can run experiments when we improve the content understanding models. Okay, so we have covered two areas in this agenda. So namely, we have covered the CU team introduction. We have also covered CU signals. Now let's come to the last bullet point, which is business impact. So in this bullet point, I'm going to talk about the different use cases. And I'm also going to talk about how we onboard our content understanding models and briefly show some impact results that we have already achieved. So in use cases, we have mainly the following three areas of content understanding use cases. The first area is explicit personalization. So the explicit personalization can include interest feed, where the user can follow certain interests, like Bitcoin. So if you follow Bitcoin, we are going to have a interest feed with content that have Bitcoin as one of the labels. So this will require us to reliably label the content with this topic of Bitcoin. Otherwise, this is going to have some bad cases. The other explicit personalization is hiding topics. Suppose you hide one topic. Suppose you hide one article in talks about crime. If you hide it, we want to prompt a window and ask you whether you want to hide all articles containing crime information. This is another use case of content understanding. Besides explicit personalization, we have a lot of implicit personalization as well. So content understanding is used implicitly without user knowing that there is content understanding signals used. For example, in user interest discovery, based on what user has engaged, we may tag the user with their interested topics. In content retrieval in recommendation systems, we have been using interest-based retrievals and also embedding-based retrievals. So interest-based retrieval essentially assigns user with some interest, like user may be interested in romantic music, etc. And then we generate a queue of articles containing romantic music, and those are the articles we can surface to this user. The second approach is embedding-based retrieval. So embedding has been used a lot in these days in recommender systems for retrievals and for ranking. The last use case is in analytics. In analytics, a few use cases, including supply-demand analysis and feed diversity metric definition. So in both of these two areas, we need to have content tagging in order to support this analysis or metric definition. In onboarding our content understanding models, we consider inline replacement to replace the existing model in production with a new model if the discrepancy between the two models is small. We also consider model results in parallel. So we generate some new traits with the newer version of the model. So the old model results versus the new model results can be A/B tested so that we can demonstrate the gain with using this improved model. We are also working on self-served content understanding experiments. So by having the self-served content understanding experiments, we have maximized content understanding agility. So whenever we iterate on our content understanding models, we can experiment to demonstrate its superiority. Now let's look at some impact metrics. So in this table, I have shown several different areas, including implicit personalization, including some metric definition. The only impact I want to point to is in L1 retrieval. So in L1 retrieval, we have been using the 100K and the KPE model in retrieval. So in our topic propensity score model, which uses the 100K topics on the content, and based on users' engagement with the content, we can associate user with certain content tags. And then we do the retrieval once we have the tags on individual users. So for the topic propensity score model launch in L1 retrieval, we were able to achieve a 1.24% lift in engagement. Similarly, we have a default topic recall for users with no interest. So for these users, during CoStar, we assign a distribution of articles, and this will be used in recall on these users. So in default topic recall, we were able to achieve 0.1 to 0.2% lift in engagement, and this is also pretty considerable. Okay, so in this presentation, I have been mostly working on talking about content understanding, giving introduction to the team roadmap, what the team is working on. I also give introduction to the signals, the different kind of CEO signals, and what models were behind the CEO signals. And eventually, I talk about the business metrics that we aim to improve as a business impact. And I have also talked about the past experiments and how these experiments were able to improve the business metrics. So this is all about today's presentation. Thank you very much for your interest.